Okay, number one, first question is domain and range. We would wanted to identify the h and the k. H here is 0, k is 0, so that's going to help us with our domain and range, or at least with the range. Domain is going to be all real numbers. The range, since a is positive, it's opening upward. It's above the horizontal asymptote. So we would say that y is greater than, not equal to, y is greater than whatever your k is, which is 0. Second question, state any transformations, and I'm just asking you to do the translations, the shifts left, right, up, down. You don't have to do the full dilations. So since h and k are both 0, there are no translations. So I'm okay with you saying none. Technically, because of that 4, there is a stretch, it stretches out or is dilated, but I'm just asking for the translations. C, horizontal asymptote. It's a horizontal line, so it's always a y equals equation in whatever your k is, which is 0. And then D is exponential growth or decay. The growth factor, the number that got raised to the x1 is 3, which is larger than 1, so that makes it growth. So then to graph it, I want to do a table of values. I always put my h in the middle and pick two numbers. I'll pick one number on each side. So -1, +1, plug them in for x. So 3 to the -1. Exponent of -1 just makes a reciprocal. So 3 to the -1 is 1/3 times 4. 1/3 times 4 is 4/3. Or 1 1/3, or 1.33. I'm going to do a decimal just because I'm going to turn around and graph it. So decimal can be helpful. Plug in 0. 3 to the 0, anything to the 0 is 1. Then multiply by 4. 4 times 1 is 4. Plug in 1. 3 to the 1 is 3. 3 times 4 is 12. I don't even know that'll fit on my graph. 1, 2, 3, 4, 5, 6, 7, 8, 9. I could probably go by 2s, or I'm just not going to put it on. I'm just going to show that it goes off my graph. So -1 and 1/3, or -1, comma 1 and 1/3 is about there. 0, 4, and then 10. You know, it'd be somewhere up here. So it goes off the graph. The asymptote was 0. So that's that x-axis. So make sure you don't cross that. Oops. And so there's my graph. Number 2, domain all real. Range. A is positive, so y is greater than the k, which is 0. Transformations, there's no h or k, so that's none, once again. So then the asymptote, y equals 0, since k is 0. We've got a 0.5 that's between 0 and 1, so that is less than 1, so it does mean it's decay. My h was 0, so I'm going to surround 0. 1/2, that's really 1/2 to the -1. Oh, well, that's 2, because the reciprocal of 1/2 is 2. So 3 times 2 is 6. Plug in 0. 1/2 to the 0 is 0, times is 1 rather. 1/2 to the 0 is 1, times 3 is 3. Plug in 1. 1/2 to the 1 is 1/2, times 3 is 3.5, or 1.5. An asymptote is at y equals 0, the x-axis. This is decaying from left to right. So it's going to approach. Make sure you don't cross that asymptote. Okay, number 3, domain is all reals. The range, since the a is negative, this is going to be a less than. Y is less than. Once again, if you're not sure why I chose that, the a value is a -2. Anytime it's a negative, we go with less than, because it's going to open down instead. Whatever our k is, which once again is 0. There's no h or k, so no translations. There's no k, so y equals 0 is the horizontal asymptote, and because the 1/4, that's the number that got raised to the exponent. You look at the number that got raised to the exponent, 1/4 is less than 1, so this is decay. Since h is 0, I surround 0 again. Plug in -1. 1/4 to -1 is 4, times -2 is -8. 1/4 to 0 is 1, times -2 is -2. 1/4 to the 1 is 1/4, times -2 is -2/4, or -1/2, -0.5. 1, horizontal asymptote at the x-axis again. All right. Number 4, domain, reals. Range. A is positive, so it's going to be y is greater than our k, which in this case is -2. I do have a k value here. So there is no h value, it doesn't shift left right, but it does shift down 2. So for my transformations, I would just say down 2. So my horizontal asymptote is y equals -2. And the growth, the number raised to the exponent is 4. That's larger than 1, so this is growth. H is 0, so I'm still going to surround 0 with -1 and 1. I get 1/4 minus 2. That's -1 3/4, -1.75. 1 minus, so I get -1, and then I get 2. At -2, I have this asymptote. Make sure you put it on there so you understand what the graph's doing and you don't cross that line. Alright, number 5, domain is all reals. Range, the a value is positive, so it's going to be greater. Y is greater than whatever our k is, which is +2. Okay, so we've got an h value this time and a k. We do the opposite sign of h, so that's really a +1. So that moves right, since it's a positive one. So right 1. K is 2, so I go up 2. Y equals, my k is 2, so y equals 2. The growth factor, or the decay factor in this case, 1/2, it's less than 1, so this is decay. I'm going to surround, so my h is 1, I'm going to surround 1 this time. So 0, 1, and 2. So when I plug in 1, that makes my exponent 0. 1/2 of the 0 is just 1. So times 2/5 plus 2. So 2 and 2/5 are 2.4. When I plug in 0, I get 2. So 4/5 plus 2, so 2.8. When I plug in 2, you can of course plug this in your graphing calculator, type it in, or plug the whole equation and use your table, either way. So I get 1/5 plus 2, that's 2.2. So those are all pretty close together. So 2.8 is about there. 2.4 is about there. 2.2 is about there. Asymptote is at 2. It's going to take a while to grow. That's all just a sketch, certainly not exact. But we get something like that. Alright, domain on number 6 is all reals. The range is a is positive. There isn't, the a value is really a 1 there. It's like 1 times 2, so it's positive. So y is greater than. There is no k, so it's 0. There's a -5 for an h value, so we go left 5. No k value, so just left 5. Y equals 0, and 2 is larger than 1, so it's growth. H was -5, so I'm going to surround -5. -6, -5, and -4. Plug in -6. -6 plus 5 is -1. 2 to the -1 is 1/2, for 0.5. When I plug in -5, I get an exponent of 0. 2 to the 0 is 1. Plug in -4. 2 to the 1 is 2. So -6. Oops, I lost my place. 1, 2, 3, 4, 5, 6, 1/2. -5, 1. And -4, 2. The x-axis serves as my asymptote. Alright, now we move into some word problems. Number 7. Initial number of bacteria is 12,000. Doubles each day, write a function. doubles each day, so we can do a growth factor of 2, and that's to the x power. There's my equation. So now after 6 days, I'm going to plug 6 into that equation. Just type that into the calculator right here. So 12,000 times 2 to the 6th. We get 768,000. Yeah, that'd be then bacteria, I guess. I'm not going to worry about a label on that one, just bacteria. Okay, tennis shoes cost $50. They increase. The cost increases every year. Write an exponential function to model the cost. So y equals the initial amount is 50. 1 plus, since it's increasing, 5.1% as a decimal is 0.051. And that's to the x. There's my equation. How much would they be? Would they cost 25 years from now? So let's plug in 25. If you want to type in 1.051 and skip the plus, you can certainly do that. I want to go to the 25th power. So $173, and I can round that to 40 cents. 173.40. Bikes. You buy a new bike for $1,500. It decreases, so we're talking about decay here. So y equals 1,500 times 1 minus 0.22 a year. Okay, so t years, they want a t there. I guess on the last one I put an x on the last one, and they said to do t. Not that big of a deal. So I guess I can fix that. It's a t instead of an x. Okay, so this one's a t. Okay, there's my equation. What is the value after 3 years? So let's plug 3 in there. So we've got 1,500 times 1 minus, or you could put 0.76. That's what 1 minus 0.22 is. Oh, sorry. I should go with 8, though. 0.78. To the 3, we're going 3 years. So 711.83. Go to the back page. Our initial amount is 7. So we've got a y equals a times b to the x. That's our formula. So our initial amount is 7. We don't know what b is. We've got an x value of -2, a y value of 28. I want to solve this for b. So I'm going to divide by 7. So we get 4 equals b to the -2. I don't really want a negative exponent, so what I'm going to do, I'm just going to go ahead and multiply by -1/2, because when I multiply those, that'll give me a +1. So that becomes b. 4 to the -1/2. Well, 4 to the 1/2 is 2, and since it's negative, it becomes a fraction, so it's 1/2. So b is 1/2. So my equation, y equals, my initial value is 7. 1/2 to the x. Right, number 11, initial value is 1/2. Got an x and a y, so at y is 40.5. Initial value was 1/2 times b, I don't know what b is, to the x, which is 2. Let's multiply by 2 to get rid of that 1/2. So we get 81 equals b squared. So to get rid of that square, I would square root. I would normally do plus minus here, but in order for this to be exponential, b has to be positive. So I get to throw out the negative here. So I'm going to allow b to be a +9, even though a -9 would answer that question. It doesn't make sense in the problem. Okay, so y equals an initial value of 1/2 times a b value of 9 to the x power is my equation. Number 12. 12 for a y value, initial value of 15. I don't know my b value to an x value of 1. So divide by 15. 12 over 15, I can simplify that. They're both divisible by 3. I get 4/5. Is b to the 1? That's b. So there's my b. So my initial value is 15 times 4/5 to the x. You, of course, could write that as a decimal, like 0.8 instead. Now solve. 4 and 8 are both powers of 2. 4 is 2 squared. 8 is 2 cubed. Multiply exponents, so distribute, so 2x plus 2. Distribute 6x plus 9. Now I know the exponents must equal each other. So 2x plus 2 has to equal 6x plus 9. Subtract 2x, subtract 9. So x is negative 7/4. Number 14. So we've got 2 to the third to the x minus 2. And 6, that'll be 2 to the negative 4. So 3x minus 6 is equal to negative 4. 3x is 2, so x is 2/3. Powers of 3, 3 squared, 3 cubed, 3 to the 2x plus 2, 3 to the 3x plus 12. So the exponents must equal each other. So x is equal to 10, negative 10 rather. All right. We've got 7 squared. So distribute 2 minus 2x. So 3x is less than 2 minus 2x. Add 2x, 5x is less than 2. So x has to be less than 2/5. Here we've got 6 to the second in the denominator, so to move it up I get 6 to the negative second. So 6 to the negative, so distribute negative 12x plus 6. So negative 12x plus 6 must be greater than 3x minus 9. So I'm going to add 12x, so I get 15x. Add 9, I get 15. Divide by 15, I get 1. So 1 is greater than x, or x is less than 1. 125 is 5 to the third. Distribute. 3x minus 15. So 2x must be less than 3x minus 15. So I'm going to, so 15 is less than x, or so x is greater than 15 then. All right, we are compounding interest. We have initial deposit of $20,000, a rate of 0.052, semi-annually, that means half a year. That's going to happen twice in a year for 3 years, so an exponent of 6. So I'm going to plug this in the calculator. $20,000 times 1 plus 0.052 divided by 2 to the exponent of 6. And I should get $23,329.97. We borrowed money at 11% compound annually. What will we pay back? Okay, so our initial amount is $59,000. 1 plus 0.11 compound annually. Well, that's only once, so I don't need to worry about that. For 2 years. I don't like this one. I think there's an error in this problem. For the sake of time, I'm going to go ahead and finish it like this, and we can talk about it in class, because this is either it's a flawed problem or I can't use this formula, because I'll be paying it back. It doesn't just sit in there for 2 years. It's not a savings account. Maybe it is. Maybe we're not paying it back until the end. If that's the case, then we would owe $72,693. It's not like it's a car payment where I'm paying on it monthly. So if I borrow for 2 years, that's what I would owe. Okay. Okay, $40,000. Interest is compounded quarterly. 1 plus 0.14 to the fourth. 4 times a year for 6.25 years, which works because we're talking about quarterly. So 40,000. 1 plus 0.14 divided by 4 to an exponent of, that'd be 25 total. So 94,529 and 80 cents. Lastly, $440. It's compounded monthly. Let's see, 0.058 divided by 12. 8 years. So 1. Oops, I forgot my 440. Okay, sorry, 440 initially. So 440 times 1 plus 0.058, compounding it monthly. For 8 years, that's 96 compounds, so $699. It'd be 0.00 if you want to go cents. All right, thanks for watching.